Okay, in this lesson we're going to talk about the frequency, period, and speed of wave. So these are learner's outcome. In our previous lesson we have learned about the amplitude and the wavelength of waves. But note that amplitude and wavelength of waves are actually not related. What do I mean by that? It means that the large amplitude doesn't mean that it must have a long wavelength. Or in fact, it also means that a large amplitude also doesn't mean that it has a short wavelength. This is a simulation to show what I meant. Okay, here we have this wave. As you can remember from last lesson, amplitude is how far it deviates from the center line, and the wavelength is how long a repetition. A peak to a peak is a wavelength. So let's just simulate. So if we change the amplitude, it means that it gets larger. Okay, the center as you can see that the green blob goes larger and larger. Or if a small amplitude, it means that it goes smaller and smaller. Notice that the wavelength actually did not change. Okay, the wavelength didn't change. It is still roughly about this size. Okay, so I change the amplitude. It doesn't change the wavelength. Okay, let's just look. Okay, so how do we actually change the wavelength? You find that we change the wavelength by manipulating this thing called frequency. So let's just play again. So if I increase the frequency, you find that this pops up and down faster. Okay, so right now you find that the wavelength seems to be shorter. Okay, but if I change the frequency lower, okay, this one actually pops down, ups and down much slower. So you see that the repetition isn't as much, and you find that the wavelength in fact is actually very long. Okay, let's just increase it slightly a bit. Okay, you find that this one goes faster, and the wavelength of it correspondingly will go shorter. Okay, so this is the wavelength. You find that it is this long, but if you increase the frequency, you find that what will happen is that the wavelength will increase, the wavelength will decrease. So in summary, you find that wavelength and amplitude are actually independent of each other. You can have a large wavelength and you have a long wavelength and a large amplitude. You can have a small amplitude and a same long wavelength. You see that the wavelength is the same. You can also have a small amplitude and short wavelength. So you find that the wavelength of this is pretty short, and binarily you can have a large amplitude, but you also have a short wavelength too. Okay, you find that there's 3 repetition. Okay, over here there's also 3 repetition over here. So just now we included a frequency. So what do you mean by frequency? The idea that just now what you saw is that it repeats itself much faster. Particles that actually vibrate up and down actually move faster. So the frequency of a wave is a way to express how the wave repeats itself by how frequently does it repeat itself in a given amount of time. The more repetition in a given amount of time, the higher the frequency of the wave. So that means that if it repeats more time, the frequency of the wave is higher. So like for example, if a wave repeats itself 10 times in 1 second, it means that it has a frequency of 10 Hertz, Hz. Okay, this is pronounced Hertz, and Hz is a unit for frequency, which actually stands for this Hertz. Another way to express how a wave repeats itself is using commonly known as the period of a wave. Since we know that a wave will repeat itself after some time, so it takes time for it to go up and down. Okay, it means that some time is known as the period of the wave. The longer it takes to repeat itself, so it goes up and down slower, the larger the period. So for example, a wave repeats itself in every 5 seconds, so the wave has a period of 5 seconds. So we can see that frequency is the number of repetitions in a second, or is usually denoted by f, and period is the length of the time passed in a single repetition, denoted by t. Using this example, if a person can do 30 push-ups in 60 seconds, you find that the frequency of his push-up is actually 30 divided by 60, or half, or you can say that it is 0.5 Hertz. What it simply means is that he did half a push-up for every 1 second. And for period is that his push-up time period would be 60 divided by 30 in 2 equals to 2. It means that for every 1 push-up, he actually took 2 seconds. So notice the difference between frequency and period. So what is the relationship between these two variables, period and frequency? So if period is equal to 1 second, what will be the frequency of this? And if the period is 2 seconds, what will be the frequency of this? Or if the period is 0.5 seconds, what will be the frequency of this? Generally, you can see in terms of pattern, the longer the period, the lower the frequency, okay, or the shorter the period, the higher the frequency. So generally, you can say that they have an inverse relationship. So you can actually sum up into this. Similarly, if 5 repetition takes 1 second, so how long does 1 repetition take? Okay, you find that if the frequency is 5, the period is actually 0.2 seconds. Okay, and if 10 repetition in 1 second, then 1 rep is equals to how many seconds? Again, you find that the pattern is 10, and then 1 rep would take 1 divided by 10 is equals to 0.1 second. And the last one will be if its frequency is 20, you find that if you want to find the period is 1 over 20 equals 0.05. So we can conclude that T is equals to 1 over F. And it's logical because F is equals to 1 over T. Next, we'll introduce the idea of speed of wave. Speed of wave is the speed of how fast the disturbance is moving out towards its destination. It means that something like this. So the disturbance is actually moving in a certain way. So it actually moves over here. So it is about how fast this disturbance moves. Okay, how fast. So by simple observation of the wave, we can obtain the speed of the wave by this formula equals to distance traveled by the wave. So if we measure the distance over here, and we take the time that actually takes to travel this particular distance, we would have the speed. But take note that it is not the speed of the medium that is vibrating, meaning that it is not how fast this moves up and down. Okay, that is actually the frequency. Okay, but it is about how fast this disturbance moves away from the source. Another way to calculate this speed of wave, or denoted by V, is using V equals to wavelength divided by period. Since we know that F equals to 1 over T, we can simply just replace this 1 over T by F. So the V is equals to F times frequency times the. So this is just a simple application of the formula. Okay, given that the frequency of the sound is 440 Hertz, the wavelength is 75 centimeter, find the speed of sound. So just throw in the formula, and you find that one point to take note is that you cannot use 75 direct. You have to convert it into meters. So over here, this one is meters, 330 meters per second. Okay. Similarly, you find that you can do the opposite. If you are given the speed of the wave, which is this number 3 times 10 to the power 8, you want to find the length of the radio broadcast, which has a broadcast frequency of 98.7 megahertz. Okay, again, you use this formula, so your speed is here. This is your this megahertz means that it's times 10 to the power 6. So you substitute in, and you just try to find the wavelength, and you have this number over here. So this is the end of the lesson. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteacherswordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.